Hello everyone. Previously we have learned the concept of electric charge. If you haven't seen it yet, I have given the link in the description box. In this video, we'll discuss the different properties of charges. I want to start this topic with a great quote of Albert Einstein. He said, "Logic will get you from A to B, imagination will take you everywhere." So, if you have better imagination, this will help you to visualize and understand the concept of science very easily. So, coming to the main topic, today we're gonna learn some of the amazing properties of electric charge. Here's the first property is the like charges repel each other and unlike charges attract each other. Here like charges means either positive positive or negative negative, and unlike charges means positive and negative. Here for visualization we are using spherical objects. You can imagine it as charged ball, but this property always exists with any shape and size charged objects. Now if you ask me why exactly like charges repel or unlike charges attract, I can't answer it. In fact, nobody can answer it because it's the rule governed by the nature which cannot be altered. For example, gravity. It always exists but nobody can answer it why. It's a rule of nature. We can only observe it or discover it. This is what physics does for us. So coming to the second property, which tells us about the additivity of charge. If a system contains Q1, Q2, Q3 up to Qn numbers of charges, then the total number of charges on the system can be represented as algebraic sum of individual charges on the system. Here, the system means a set of things working together as a part of mechanism or interconnecting network. Now the third property is one of the most interesting one. It's called conservation of charge. Charge is conserved. It is not possible to create or destroy the net charges of an isolated body or system. Here the word conserve means protect from harm or destruction. You can neither create a new charge nor destroy an existing charge, but you can transfer it from one object to another. Earth is isolated in the space from other planets or stars, so net charge of the Earth is neither be created nor destroyed. Net charge is always constant until or unless some charged objects been carried away or carried towards the Earth by the spacecraft from space. Now the fourth property is the quantization of charge. This principle states that charge of any system is quantized. The charge of any body can be represented as the integer multiple of the charge of the elementary particle. That's why we can write the total charge is equal to some integer into charge in the elementary particle. Here n means some integer, where n can be either some negative value or 0 or positive value, but n cannot be something like 1.4. And E is the charge carried by the elementary particle. Now, what is elementary particle? We know that the subatomic particles are the elementary particles. Here we have the electron, proton and neutron. Electron carries a negative charge, proton carries positive charge, and neutron is neutral. And the charge of electron equal to the charge of proton, which is equal to 1.602 into 10 to the power minus 19 coulomb. But they are of opposite polarity. So the magnitude of charge carried by the elementary particle is 1.602 into 10 to the power minus 19 coulomb. These four are the main properties of charges. We'll encounter different behaviors of charges in the later chapters. In the next video, we'll discuss different ways of charging a body.